I'm Shantanu Bokey, a software engineer with around 2 years of experience working at Oxford Systems. My main work is around building full stack applications using technologies like React, Next, Nest, Node, Postgres, and AWS. I have worked on backend APIs as well as front-end dashboards, authentication flows, database design and management, and AI-based workflows. Today I'm going to present my hackathon project, that is InterviewCoach AI. So basically, InterviewCoach AI is an AI-powered interview preparation platform that helps candidates practice realistic technical and behavioral interviews using real-time voice conversations and instant feedback. Now let's move towards the presentation, and after that, I will give a live demo of the application. So, coming to the problem I'm solving is that interview preparation is still very difficult to practice realistically. Most candidates either use generic question banks or depend on human mock interviews, but generic questions do not understand the candidate's resume, experience level, or target job role. And human mock interviewers are expensive, hard to schedule, and the quality can vary. Another major issue is feedback. After practice, candidates usually don't get a structured scored, evidence-based feedback, or a clear improvement plan. So today, many candidates are preparing without proper structure, personalization, or measurable feedback. Now coming towards the solution. To solve this, I built InterviewCoach AI. It provides personalized AM of interviews with instant feedbacks. The application takes the candidate's resume and job description as input and then generates role-specific technical and behavioral questions. Instead of just showing static questions, the user can have real-time voice conversation with the AI interviewer. The AI listens, asks follow-up questions, and creates a natural mock interview experience. After the interview ends, the platform generates analytics like readiness score, answer level feedback, strengths, weaknesses, and sample improved answer. So the goal is to give candidate a complete interview preparation toolkit in one place. Now coming towards the tech stack. For the tech stack, I used a modern full stack architecture. On the front end, I used Next.js, React, Tailwind CSS, React Query, and Justin for building a faster and interactive user experience. On the backend, I use Nest.js with Node.js, Prisma ORM, and REST API. For the database, I use Postgres with Prisma migration. The most important technical part is the AI and voice layer. I use the OpenAI's real-time API with WebRTC for low latency voice streaming. For resume parsing and feedback generation, I use the GPT-based feedback engine. For storage, the application supports secure file handling and resume parsing. The project is structured as turbo repo, monorepo with separate web and API apps and shared types and file utilities. So the target audience for this interview coach AI is broad. So basically, it can help students preparing for campus placements, fresh graduates applying for their first job, software engineers preparing for technical interviews, and career switchers who want to switch the roles to a specific practice. It can also be used for bootcamp learners, coaches, and recruiters who want scale mock interview support. The main idea is simple. Anyone preparing for interview should be able to practice anytime, get personalized questions, and receive clear feedback after every session. Now we will move to live demo of the application.
So this is basically the landing page of our website for Interview Coach AI. So we have options to sign in or start practicing free. We'll go through how it works. So basically, the first step is to upload and configure. Upload your resume, paste the job description, and select your experience level. Then practice with AI. The AI interviewer will ask tailored questions via voice and responds naturally, just like a real interviewer. Then the third step is to get the feedback, which will include readiness score, per answer feedback, and sample answers. Now let's start with the interview. Yeah, so you can either create your account or just sign in. So this is how the dashboard looks. It shows stats for total number of interviews, resumes uploaded, average score, and hours practiced. Then from here you can select the resumes and start the interview. Then we have resume management where you can upload multiple resumes. Then we have history, which will show how you perform over a certain time period. Then you get all the history of all the interviews conducted with the feedback. So now, okay. Let's start with the new interview. So I have already uploaded my resume and I'm selecting it now and we'll move to next step. So here we can paste a generic SD1 job description. Then moving on to next step, we can select experience level. We have four experience level: fresher, junior, mid level, and senior. Let's select junior.
Hi Shantanu, I'm Alex. This is a structured junior interview for an SDE1 role. There will be 6 assessed questions total, covering technical, behavioral, and scenario topics. Please give me a 60-second introduction covering your background, key experience, and what interests you about this role.
Hi Alex, I'm Shantanu Bokey, a software engineer with around 2 years of experience, currently working at Roxel Systems. My experience is mainly building full stack applications, especially using Next.js, React, TypeScript, Nest, Postgres, and AWS. On the backend side, I have worked on scalable APIs, authentication, database workflows, async work processes, and cloud-based deployments. One of my key experiences was working on an ATS platform where I helped build candidate search workflows using OpenSearch, Boolean search, profile indexing, and retrieval-based filtering. I've also worked on AI-focused projects like AI resume analyzer and interview coach. What interests me about this role is opportunity to solve real engineering problems, write clean and maintainable code, and keep improving across backend, frontend, cloud, and system design. I'm looking for a role where I can contribute actively, learn from stronger engineers, and grow into a better software developer.
First, technical question. Imagine a backend API that's suddenly slow in production after a new release. You're using Nest.js with PostgreSQL. What's your step-by-step approach to find the bottleneck and confirm the fix?
I would approach it in a structured way. First, I would confirm the impact by checking metrics like API response time, P95 or P99 latency, error rate, CPU, memory, and database load. Then I would compare these metrics with previous release to understand what changed after deployment. Next, I would check the application logs for slow endpoints, exceptions, timeout error, or any increase in external API call. If tracing or request logs are available, I would identify which specific route became slow. After that, I would move to database. I would check slow queries, active connections, logs, connection pool usage. For suspicious queries, I would run explain analyze to verify whether indexes are being used or whether the query is doing a full table scan. I would also check if the new release introduced any n+1 query issues or an expensive join. Then I would review the recent code changes, database migrations, and environment changes. Once I identify the bottleneck, I would fix it, test it locally or staging, and if needed, run a small load test.
Second technical question. You have a PostgreSQL backed queue and worker processes for asynchronous tasks, like indexing candidates. How would you design the worker logic to be reliable and idempotent so retries don't create duplicates and tasks aren't lost?
So I would design it with two goals. First is no task should be lost, and second is retrying the same task should not create duplicate side effect. For the queue table, I would keep the fields like ID, task type, payload, status, attempt count, locked at, locked by, next retry at, and timestamps. Workers would pick jobs using transactions with for update skip logged, so multiple workers can run safely without processing the same job at the same time. When a worker picks a job, I would mark it as processing, increment the attempt count, and set a lock time. If the worker crashes, another worker can later pick it up again and after the lock expires. For idempotency, I would make the actual operation safe to repeat. For example, in candidate indexing, I would use the candidate ID as the unique document ID in OpenSearch. So if the same indexing task runs twice, it updates the same candidate document instead of creating duplicates. On the database side, I would use unique constraint or idempotency key where needed.
Third technical question. In a REST API for an ATS search feature, what trade offs do you consider between using OpenSearch versus relying more heavily on SQL filtering? And when would you choose one over the other?
So for an ATS search feature, I would choose based on the type of search requirement. If the search is mostly structure filtering, like filtering candidates by status, location, experience range, created date, or exact fields, then Postgres is simpler and reliable. SQL is easier to keep consistent because it works directly on the source of truth, and we can optimize it with proper indexes, joins, and pagination. But if the search needs full text search, Boolean search, ranking, fuzzy matching, skill matching, or retrieval based filtering, then OpenSearch is better fit. In an ATS recruiter, usually search using keywords like Java, and Spring Boot or React or Next.js, and they expect relevant candidate profiles to come first. OpenSearch handles that much better than plain SQL. The trade-off is that OpenSearch adds extra operational complexity. We need indexing pipelines, sync workers, re-indexing logic, and we must handle eventual consistency between Postgres and OpenSearch.
Fourth, technical question. Describe a practical way you've used Git and code reviews to keep code quality high in a small team, especially when shipping a small feature end to end.
In a small team, I usually try to keep the Git workflow simple but disciplined. For a small feature, I first create a separate feature branch from the latest main branch or the develop branch and keep my commits focused, like one commit for backend API change, one for database change, and one for front-end integration if needed. I also try to write clear commit messages so the reviewers can understand the purpose quickly. Before raising a pull request, I make sure the code builds, test passes, and I do a basic self-review. In the PR description, I explain what was changed, why it was changed, how it was tested, and mention any database migration or API contract change. During code review, I focus on maintainability, edge cases, error handling, naming, and whether the feature fits the existing architecture or not. For example, in a full stack feature, I check that the API response structure is clean, validation is handled properly, and the frontend is not tightly coupled to backend internals. Once feedback is resolved and the PR is approved, we merge it safely and monitor logs after deployment. So the main idea is small branches, clear PRs, self-review, peer review, and post-release verification.
Behavioral question using STAR. Describe a time you owned a small feature from design to release. What was the situation? What actions did you take? And what was the result?
One example was a candidate search feature I worked on for an ATS platform. The situation was that recruiter needed a faster and more relevant way to search candidate profiles using skills, keyword, and filter. Basic SQL filtering was not enough for more advanced search cases like Boolean search and profile-based matching. My task was to help build the backend workflow for candidate discovery and indexing. I worked on the API side, OpenSearch integration, and asynchronous workflow so candidate profiles could be indexed and searched reliably. For the action, I first understood the search requirements, then helped design how candidate profile data should be indexed. I worked on backend APIs in the Next.js Postgres backed queue workflow and worker process for indexing and search synchronization.
Okay, let's walk through a realistic incident and how you'd handle it step by step. Scenario question. A recruiter reports that search results look stale right after candidate updates. You suspect eventual consistency between PostgreSQL and OpenSearch. What do you do?
Here you can see the interview feedback repo. You will get various stats here. You will also get top strengths area to improve executive summary. Then we also have transcript evidence where you will see questions asked by the interviewer and the answers by the candidate. At last, you will get score for each question, and there will be detailed feedback and ideal sample answer that was required from the candidate. We can also check the history here, which will also show us the graph of performance trend.